the strange foundations of quantum reality. In the stillness of the night, when the world outside goes quiet, your mind can drift into the invisible realm where atoms dance, particles shimmer, and certainty dissolves into probability. Welcome to quantum physics, a realm more bizarre than any dream, yet it governs the very fabric of our universe. Let's begin with something simple, or so it seems. Everything you see is mostly empty space. Atoms make up everything, your pillow, your blanket, the stars above. But did you know that atoms are 99.9 trillion, 999 billion, 999,996% empty space? If the nucleus of an atom were the size of a peanut, the atom itself would be the size of a football stadium. That means you, right now, are mostly made of emptiness, and yet you feel solid. Why? Because of the electromagnetic forces between particles. It's not that your hand touches the bed, it's that the fields between their atoms repel each other. From this simple idea of emptiness emerges the first quantum mystery. Particles can exist in multiple states at once. This is the famous concept of superposition. In classical physics, a ball is either here or there, but in the quantum world, particles like electrons can be in a mix, here and there, spinning up and down, all at once. They don't choose a state until someone measures them. Imagine flipping a coin and it being both heads and tails, until you look, and this brings us to an even stranger truth. Observation changes reality. In the double-slit experiment, when electrons are fired at a barrier with two slits, they behave like waves, creating an interference pattern. But when we observe them, they suddenly act like particles. The very act of watching changes the outcome. Reality, it seems, behaves differently when we're not looking. But what is it that watches? Is it a machine? A conscious being? That mystery leads to philosophical debates still unresolved today. A particle can affect another instantly, even across galaxies. This is called quantum entanglement. When two particles become entangled, their properties are linked no matter how far apart they travel. Change one and the other changes instantly, faster than the speed of light. Einstein called this a spooky action at a distance, yet it has been proven over and over again. Entanglement might be the thread that connects the cosmos, and this connection could even hint at how the universe is stitched together beneath what we can see. Time might not be as solid as we think. In quantum mechanics, time isn't always a flowing river. In fact, certain interpretations suggest that time could be an illusion, or at least emergent. Some physicists believe time itself arises from quantum entanglement, from relationships between particles, rather than ticking clocks. So as you breathe in and out, slowly, remember, your sense of time may not reflect reality. It may only be the way your mind orders a deeper, timeless sea of quantum events. Reality might be just information. Quantum bits, or qubits, are the building blocks of quantum computers. Unlike regular bits, which are either 0 or 1, qubits can be both at once. The very nature of reality may be made of such bits of information. Some theories, like it from bit idea proposed by physicist John Wheeler, suggest that everything in the universe, matter, energy, even space and time, arises from information. If so, then the universe is not just a place but a kind of computation, running quietly, eternally, in the background. Virtual particles appear and vanish constantly. Even in the emptiest vacuum, particles are popping in and out of existence. These are called virtual particles, and they live for just a tiny fraction of a second. They can affect real forces, like the Casimir effect, which pushes metal plates together in a vacuum due to the pressure of these ghostly particles. Your body, your bed, even the silence around you, is filled with the buzz of things that exist only for a moment, then vanish unseen. Light behaves as both a wave and a particle. Sometimes light acts like a wave, spreading out and interfering with itself. Other times it acts like a particle, a tiny packet called a photon. This duality puzzled scientists for decades, and even now, we don't fully understand why nature needs both descriptions. Yet every beam of moonlight, every glow of your night lamp, dances to this rhythm of duality. You can tunnel through barriers. Quantum tunneling allows particles to pass through walls, even when they don't have enough energy to do so. This isn't science fiction. It's how the sun burns, by allowing protons to overcome their natural repulsion through tunneling. The vacuum of space has energy. Even empty space has a measurable energy called zero-point energy. This energy might be responsible for the mysterious dark energy that's accelerating the expansion of the universe. And some dreamers believe that one day we might harness it to power cities, ships, maybe even dreams. You're floating now gently in a sea of mysteries, each more soothing than the last. Schrödinger's cat is both alive and dead, until it's not. This thought experiment was never meant to be taken literally. Schrödinger wanted to show how strange quantum rules seem when applied to big things, like a cat in a box whose fate is tied to a quantum event. Until the box is opened, the cat is both alive and dead. The point, quantum weirdness doesn't go away just because things get bigger. It lingers, even in your fingertips, even in your breath. Particles have no fixed position, only probabilities. The Heisenberg uncertainty principle says we can never know both the position and momentum of a particle exactly. The more we know about where it is, the less we know about how fast it's going, and vice versa. That means reality is smeared out like mist over a still lake. You're not just lying in bed, you are part of this quantum blur, relaxing into uncertainty, floating in probability. And so, from one fact to the next, we drift, effortlessly deeper into this hidden universe. Beneath the surface, hidden patterns of the quantum world drift deeper now, past what the eyes can see and what the mind can fully grasp. The quantum world isn't just strange, it's layered. There are patterns hidden beneath patterns, mysteries tucked beneath every certainty. It's not a place of logic, it's a place of elegance. Let's begin with something beautiful. Electrons don't orbit atoms the way planets orbit the sun. In school, we often imagine electrons spinning neatly around a nucleus like miniature solar systems, but that's not quite how it works. Electrons exist in clouds of probability, fuzzy zones where they might be found. These are called orbitals, and their shapes are elegant. Spheres, dumbbells, blossoms of possibility. So when you look at your hand, what you're really seeing is a blur of probabilities. The universe might be governed by symmetries. Deep inside particle physics is a simple truth. Symmetry often leads to conservation. Symmetry in time means energy is conserved. Symmetry in space means momentum stays constant. Physicists build entire theories based on these invisible balances. They're not just equations, they're the quiet harmonies of nature. It's as if the universe prefers to keep its rhythm even in chaos. Antimatter exists, and it mirrors everything. For every particle, there's an antiparticle. An electron has a positron. A proton has an antiproton. When matter and antimatter meet, they annihilate in a flash of energy. But here's the puzzle. The Big Bang should have created equal amounts of matter and antimatter, yet somehow matter won. You, your bed, the stars, all exist because of a tiny imbalance no one yet understands. In a mirror universe, perhaps you're made of antimatter, quietly dreaming the same dream. Vacuum energy could create entire universes. Physicists believe that in a high-energy quantum vacuum, inflationary bubbles could randomly form and expand rapidly to become entire universes. That means the birth of our universe may have been a quantum fluctuation, just a moment of uncertainty that never ended, and that might mean there are countless other universes still bubbling up just beyond our reach. Quantum fields might be more real than particles, In modern physics, particles are seen as ripples in underlying fields, like waves on an invisible ocean. The electron isn't a tiny marble. It's a ripple in the electron field. Photons are ripples in the electromagnetic field. These fields fill all of space, silent, eternal, yet capable of creating everything. The room you lie in is soaked in fields you cannot feel, but they are more real than the ground beneath you. Reality may be non-local. In our everyday world, cause follows effect, and things happen in definite places. But in quantum physics, non-locality suggests that actions in one place can instantaneously affect things elsewhere. It's not that signals travel faster than light. It's that space itself might not be what we think it is. Imagine space as a quilt, folded in ways we can't perceive, folded so tightly that faraway places may actually be side by side. Time reversal symmetry exists, but it's not always obeyed. The equations that govern particle interactions often work the same forward or backward in time, but not always. Certain rare reactions, like those involving strange particles called canyons, show a preference for moving forward. This tiny asymmetry might be why time flows in one direction, and why we remember the past but never the future. You are carried forward not by clocks, but by cosmic preference. Quantum mechanics underlies chemistry and life. Why does oxygen bind with hydrogen to make water? Why do enzymes work? Why can sunlight trigger photosynthesis in a leaf? Behind every answer is quantum mechanics, dictating how electrons jump, how atoms bond, how energy flows. Even your thoughts, your dreams tonight arise from quantum behavior in the brain's synapses. So in a way, your very act of falling asleep is a quantum event. Particles can interfere with themselves. A single particle, just one, can pass through two slits and create an interference pattern. It's as if the particle goes through both paths at once and interferes with itself. This isn't imagination, it's measured in labs. Even massive molecules, thousands of atoms wide, have been shown to exhibit this behavior. The universe doesn't ask, where is it? It asks, where could it be? You can't clone a quantum state. In quantum mechanics, there's a principle called the no-cloning theorem. You cannot create an exact copy of an unknown quantum state. This isn't a technological limitation. It's a law of nature. You can measure it, but doing so changes it. You can entangle it, but you can't duplicate it. Each quantum moment is unique, unrepeatable, like each breath you take tonight. Quantum physics helps explain black holes. Black holes aren't just gravitational monsters. They also radiate particles through Hawking radiation, a quantum effect at the event horizon. Over immense timescales, this means black holes can evaporate. A phenomenon driven not by gravity, but by the jittery chaos of virtual particles near the edge of space. Even the darkest places in the universe whisper in quantum tongues. Quantum randomness is real, not just ignorance. In classical systems, randomness is just a placeholder for things we don't fully understand. But in quantum systems, randomness is fundamental. No hidden cause, no deeper clockwork. When an atom decays or a particle chooses a path, it does so with genuine unpredictability. The universe rolls its own dice, softly, quietly, with every passing second. So as your eyes grow heavier and your thoughts dissolve into stardust, know that beneath the surface of all things lies a vast humming ocean of mystery. Patterns without pattern, logic without logic, a dream within a dream. When dreams become reality, the quantum creation of everything as you lie there in the stillness, with your breath slow, your heartbeat gentle, imagine this. Everything you touch, everything you see, everything you are might not be made of things, but of possibilities collapsing into existence. At the edge of dreams and matter, quantum physics is not just describing the world, it's creating it. Let's begin again softly. Reality forms when you observe it. In quantum physics, until something is measured, it exists in a state of superposition, many possible outcomes all stacked atop one another. But the moment you look, the wave function collapses and one possibility becomes real. In this way, observation creates reality. Not in a magical sense, but in a deeply physical one. It's as if the universe waits in silence until someone listens. The quantum Zeno effect can freeze time. This odd phenomenon shows that if you observe a quantum system repeatedly, you can prevent it from changing. It's called the quantum Zeno effect, after the ancient philosopher who argued that an arrow in flight is frozen in time when seen at every moment. And in the quantum world, it's real. The very act of watching stops the action. Imagine a candle that never melts simply because you never blink. Delayed choice experiments suggest the present affects the past. In some experiments, a decision to measure a particle's path, made after it has passed through a system, appears to determine what it did earlier. It's as though the present rewrites the past. This doesn't allow for time travel, but it challenges our deepest intuitions about cause and effect. The future, it seems, leaves footprints in yesterday's snow. Quantum biology may influence how birds navigate. Certain migratory birds may use entangled particles in their eyes to sense Earth's magnetic field, allowing them to navigate across continents. If true, this is quantum physics at work inside a living being. A compass made not of metal, but of probability and light. And right now, as you rest, somewhere in the sky, a bird follows the stars, guided by entanglement. Quantum tunneling may power your DNA. Enzymes in your body rely on protons and electrons jumping from one place to another, even through energy barriers they shouldn't cross. This process, tunneling, ensures that life continues. It's not just a cosmic trick, it's happening right now in your cells. So your very breath, your heartbeat, the calm in your chest, may be a quantum miracle. Information might be the fundamental unit of existence. More and more physicists believe that information, not matter or energy, is the most basic ingredient of reality. Atoms store it, particles transmit it, black holes trap it. And according to the holographic principle, our 3D universe may even be a projection from a 2D surface storing this data. You are not just made of atoms, you are made of answers and the questions they whisper. The universe might be a quantum computer. Some theoretical physicists propose that the cosmos itself behaves like a vast quantum computer, processing information at every level. Galaxies, stars, you, all part of the computation. What is it calculating? No one knows. Perhaps it's not calculating anything. Perhaps it simply is. A universe dreaming of itself through logic and wonder. Schrödinger's equation governs the entire universe. This single equation describes how quantum systems evolve over time. It's not flashy. It doesn't predict a cat's fate or bend space like Einstein's relativity, but it works. It governs atoms, molecules, even stars. A gentle wave of mathematics that guides all things in silence. Imagine the quiet hum of this equation softly flowing through everything you know. Quantum computers can do the impossible. Unlike normal computers, which calculate step by step, quantum computers use superposition and entanglement to perform multiple operations at once. They can factor huge numbers, solve impossible problems, simulate molecules. And they are real, being built right now. Somewhere deep in a lab, a machine dreams in quantum logic, speaking the universe's native language. Reality emerged from entangled bits of space-time. New research hints that space and time themselves may emerge from entanglement between tiny bits of information. In this view, space-time isn't fundamental. It's built like a fabric, stitched together by quantum threads. Without entanglement, space may collapse. Without it, there is no where, no when. So maybe you're not lying on a bed in a room. Maybe you're floating in a tapestry of entangled dreams. At Planck scale, the universe becomes pixelated. There's a smallest possible length, the Planck length, below which space may no longer be smooth. Just as a digital image blurs into squares, space at this scale becomes grainy, discrete. The universe is not a painting, it's a mosaic. And somewhere within that mosaic is you, a part of the pattern, a tile in the infinite. Quantum foam may be the true texture of space. At the tiniest scale, space-time may seethe with activity, fluctuations, loops, wormholes appearing and vanishing in the blink of a Planck time. This chaotic sea is called quantum foam. It's not something we can see, but it might be the ground floor of all reality. You sleep above a sea you'll never touch, yet it holds you gently always. And now as your thoughts drift even farther, The lines between dream and truth begin to dissolve. Particles blur. Time softens. You've reached the edge where physics becomes poetry and sleep becomes your vessel. The quantum horizon where science meets the unknown, you are now drifting far beyond what science can explain, into a space where even physicists must whisper, because here questions outnumber answers. And yet quantum theory still provides the map. A soft, shimmering map written in probability stitched with paradox. Let us step gently across that threshold. Reality may not exist until it is measured. The Copenhagen interpretation, one of the oldest understandings of quantum mechanics, says that particles don't have definite properties until they're observed. Until then, they exist as a cloud of possibilities. That means, until you look, a particle is not here or there, but both. And reality itself, it may wait for you to arrive before taking form. Imagine a world that waits to be dreamed into being. Some particles appear to know the future. In delayed choice quantum eraser experiments, particles behave as if they know how they will be measured before the measurement happens. It's as if the particle adjusts its behavior based on something that hasn't happened yet. This isn't science fiction. This is peer-reviewed physics. Time doesn't run like a river here. It swerves like mist. There may be multiple versions of you. The many worlds interpretation suggests that every quantum decision splits the universe into branches. In one universe, the photon goes left. In another, it goes right. And in every decision you make, every breath, every blink, the universe may split again. Somewhere, there is a version of you who didn't turn off the lights, one who never learned quantum theory, one still awake, and yet here you are, in this universe following this thread, gently. Consciousness might be linked to quantum processes. Some theories, like orchestrated objective reduction, or ORCHOR, suggest that consciousness arises from quantum effects in the brain's microtubules, tiny structures inside your neurons. While still speculative, this theory hints that awareness may not just use quantum mechanics, maybe quantum mechanics. Your thoughts tonight? They may shimmer with quantum echoes. Quantum particles don't have identities. In classical physics, if you swap two marbles, you still know which is which. But in the quantum world, particles like electrons are fundamentally indistinguishable. If you switch them, you cannot tell. It's not just hard, it's impossible. They have no this one, sure that one. Only presence, only wave functions. In the quiet dark, perhaps you two are not a this or a that, just here. Quantum fluctuations may have created the Big Bang. It's possible that the universe was born from nothing. Not in the philosophical sense, but from a quantum fluctuation in a vacuum. From absolute emptiness, a tiny, high-energy bubble emerged, inflated and expanded into everything. That means the stars, the galaxies, your pillow were once a ripple in the void. Even your calm tonight began in chaos. There are infinite ways to interpret quantum mechanics. No one knows what quantum mechanics truly means. There's Copenhagen, many worlds, Bohmian mechanics, cubism, superdeterminism. Each offers a different picture, yet all describe the same experiment. Quantum physics is like a language spoken by a world we don't fully understand. The words are precise, the meaning, elusive. And so we listen, not to understand, but to feel the music. Particles can be in forbidden places. In classical terms, a particle shouldn't be where it doesn't have the energy to be. But quantum mechanics doesn't care. Electrons can appear in places classical physics forbids. This is called quantum tunneling, and without it, nuclear fusion and stars would be impossible. So, even when something seems impossible, it might still happen, quietly, miraculously. Information never truly disappears. Even when matter falls into a black hole, information may not be lost. This is called the black hole information paradox. Quantum theory demands that information is preserved, somehow. Some theories suggest that Hawking radiation encodes it. Others say black holes are holograms. One idea even suggests reality itself is a giant information processor conserving every whisper of existence. That means nothing you've ever done is truly gone. Somewhere in the fabric of the universe it echoes. Quantum mechanics and gravity don't yet agree. Despite both being incredibly successful, quantum mechanics and general relativity are incompatible at fundamental levels. Merging them into one unified theory, quantum gravity, is the holy grail of physics. Candidates like string theory and loop quantum gravity try to reconcile them, but the answer remains just out of reach. The universe, it seems, still guards its final secrets. Quantum experiments can defy logic, but never the math. Time loops, cats that are dead and alive, particles that talk across galaxies. These sound like fantasy, but every quantum experiment confirms the same truths. The logic is strange, but the math is perfect, always. You don't have to understand the quantum world. You only have to trust its gentle rhythm. Quantum reality might be shaped by you. Some interpretations argue that consciousness, observation, and reality are intertwined. When you look, the particle chooses a path. When you sleep, the wave function drifts, waiting for the next dreamer. Your awareness might not just observe the universe. It might shape it. So tonight, in your stillness, you help decide what is real. And so we rest floating in a universe of paradox, where knowing less lets you feel more, where silence holds answers, where the unknown is not something to fear, but something to fall asleep to. The light between worlds, when particles dance with the infinite somewhere between the beat of your heart and the silence of the stars. Light moves. Not just the light we see, but the fundamental quanta, the photons that stitch the cosmos together. They move in packets and waves and uncertainty, and they are messengers of everything that has been and everything that might be. So let's follow them now without moving at all. Light is both a wave and a particle, always. This dual nature is one of the most beautiful paradoxes in quantum mechanics. Shine light through two slits and it creates an interference pattern, like a wave. But detect which slit it passed through, and the pattern disappears. The photon becomes a particle. This isn't a trick, it's the nature of reality. Light doesn't choose what to be, it simply is and becomes what we ask of it. A single photon can take multiple paths. In a quantum system, a photon doesn't just go left or right. It explores all possible paths simultaneously. This is known as the path integral formulation developed by Richard Feynman. Only when measured does the photon seem to have taken one route. The universe, in its quiet, invisible way, always keeps its options open. Photons don't experience time. From a photon's perspective, time does not pass. It is emitted and then absorbed instantly from its point of view. This is because photons travel at the speed of light and time stops at that speed according to relativity. So that sunlight hitting your skin, from the photon's view, it left the sun and reached you in the same moment. You are touched in this very second by something that never knew delay. Quantum electrodynamics, KED, is the most accurate theory ever. KED describes how light and matter interact, how photons are exchanged between electrons, how atoms glow, how lasers beam, and its predictions have been confirmed to more than 10 decimal places. It is the most precise theory in history, and yet it depends on virtual particles and invisible fields that challenge intuition. Even in mystery, nature has perfect handwriting. Virtual particles carry real effects. Though they cannot be seen or directly measured, virtual particles affect reality. In the Casimir effect, two metal plates in a vacuum are pushed together, not by any visible force, but by the pressure of virtual particles. The void, it turns out, is not empty. The silence around you tonight is alive with invisible conversations. Lasers are a triumph of quantum order. Light from a lamp is chaotic, each photon going its own way. But a laser, it's order. All photons move together in phase and harmony. This quantum coherence powers everything from barcode scanners to surgeries. It's light behaving like a symphony. One note multiplied across the void. Atoms emit light in quantum jumps, not slides. When an electron in an atom changes energy levels, it doesn't glide smoothly. It jumps, disappearing from one level and reappearing at another. This quantum leap emits or absorbs a photon. There is no in-between, just a blink, a shift, a moment of pure transformation. And so every light you see is made of sudden decisions. You cannot perfectly copy a beam of light. The no-cloning theorem of quantum mechanics says you cannot create an exact replica of an arbitrary quantum state. So even if you know everything about a beam of light, you can't duplicate it exactly. This is why quantum encryption is so powerful. It cannot be copied without changing the message. Even light, it seems, guards its secrets carefully. Quantum teleportation is real for light. Scientists successfully teleported the quantum state of photons from one place to another using entanglement. No matter moves, just the information, perfectly reconstruct distance. Not science fiction. Science fact. One photon and two hearts until one becomes the other. Coherence connects photons across time. Photons produced in certain ways, such as in down conversion or atomic cascades, can remain entangled across time. Measure one, and the behavior of the other is instantly affected even if it was emitted earlier. Time once again becomes soft. It's not just space that quantum physics bends. It's the thread of memory itself. Light bends not just by gravity, but possibility. In classical physics, light bends when it passes through glass or water. In general relativity, it bends around stars, but in quantum field theory, even the vacuum can bend light slightly through interactions with virtual particles. Light follows curves not just in space, but in potential. It moves through what could be as much as what is. Light may reveal hidden dimensions. Some advanced theories, like string theory, predict extra dimensions beyond our familiar three. These hidden spaces might subtly affect how photons travel through space, causing tiny anomalies in light's behavior. We haven't found them yet, but light may be our key. Every glow, every shimmer may be a message from another layer of the universe. And now as your mind floats on waves of light and silence, know that the same rules guiding distant starlight also cradle you tonight. You are not outside this quantum world. You are inside it, carried by it, made of it. Let it hold you gently. At the edge of everything, black holes, wormholes, and quantum horizons. Now, imagine yourself drifting farther, beyond the atoms in your pillow, past the molecules in the air, past the stars outside your window. You are approaching the edge, not of danger, but of understanding. A place where gravity becomes silence and space itself curves inward. Welcome to the quantum frontier. Black holes are where quantum physics and gravity collide. Black holes are the ultimate paradox. Formed from collapsed stars, their gravity is so intense that not even light can escape. Yet inside, quantum rules still apply. What happens at the boundary, the event horizon, remains one of the deepest mysteries in science. It's the place where everything ends and maybe begins again. Black holes radiate, slowly dying. According to Stephen Hawking, black holes are not perfectly black. They emit Hawking radiation, caused by quantum effects near the event horizon. Virtual particle pairs appear, and one falls in while the other escapes. Over trillions of years, this slow leak may cause black holes to vanish completely. Even the darkest things eventually let go. Information may escape from black holes. For decades, scientists believed anything falling into a black hole, matter, light, information, was lost forever. But quantum theory insists information is conserved. The challenge of reconciling these ideas gave rise to the information paradox. Now, theories like the holographic principle suggest that information might be stored on the event horizon, projected like a cosmic movie screen. So what falls in may never be gone, only transformed. Wormholes are allowed in quantum theory. A wormhole is a tunnel through space-time, a shortcut between two distant points. Einstein and Rosen first proposed them. Later, quantum theories explored the idea that microscopic wormholes might constantly flicker into existence. If stabilized, they could connect galaxies or moments. Imagine lying in bed and being gently pulled to a star on the other side of the universe, not by speed, but by stillness. Entanglement might be the fabric of space-time. Some scientists believe space-time itself emerges from entangled particles. If true, then entanglement is not just a strange property, it's the thread from which reality is woven. This would mean gravity, time, even space. Quantum fluctuations near a black hole can create particles. Empty space is never truly empty. Near the surface of a black hole, energy fluctuations become so intense that they can turn into real particles. These particles can escape, adding to Hawking radiation. The black hole, in its silence, sings a soft, constant song, one we are only beginning to hear, and somewhere that song drifts across the galaxy, unchanged for eons. Time slows near massive objects. According to relativity, time ticks more slowly near massive gravitational bodies. Near a black hole, this effect becomes extreme. A few minutes for someone near the event horizon could mean centuries have passed for someone far away. From their view, you are frozen. From yours, the universe rushes ahead, and still you are safe, suspended in your own moment. Inside a black hole, the laws of physics may break. At the center lies a singularity, a point where density becomes infinite and our equations fall apart. No one knows what happens there. Some believe space and time cease to exist. Others think new universes could form. We cannot see it, but we can imagine it, not as a place of fear, but of creation. The universe might be born from a black hole. Some theories suggest that the Big Bang was not the beginning, but the bounce of a collapsing universe, or even the other side of a black hole in a higher dimension. If true, every black hole in our universe might give birth to a new cosmos. So the next time you look at a night sky, imagine you might be inside one. Quantum loop gravity offers another view. While string theory imagines tiny vibrating threads, loop quantum gravity suggests space is made of loops, tiny units of volume woven into a web. These loops form the geometry of the universe. Even time may come in tiny quanta. There is no between, only flickers, steps. The universe may not flow. It may tick softly, one dream at a time. The boundary of a black hole is not fixed. As it emits radiation, the event horizon of a black hole slowly shrinks. But what defines this boundary? Not a solid surface, but a point of no return, always shifting, always defined by context, like the edge of sleep, a moment not marked but felt. You don't fall asleep all at once. You drift across a horizon of thought. Somewhere out there, white holes may exist. If black holes suck matter in, white holes might do the opposite, spitting matter out but never allowing anything in. They are theoretical, never seen. But in the dance of quantum possibilities, they are not forbidden. Somewhere in a quiet corner of reality, something may be glowing, pushing the universe outward, a cosmic exhale, a release. So now as you rest at the edge of all things, where light bends and time slows and space whispers, you are part of the mystery, not just a listener, but a participant. And the universe is dreaming with you. The quantum in you strange science behind everyday life. The quantum world may seem distant, like something hidden behind microscopes or buried in space-time equations. But the truth is, you are made of quantum rules. The way you breathe, think, see, and sleep. All these moments are touched by invisible laws unfolding silently. So let's turn inward now and see how the universe lives in you. Your vision starts with quantum events. When you see, you're detecting photons, particles of light striking your retina. A single photon can trigger a chemical reaction in a molecule called rhodopsin, sending a signal to your brain. That's right. Your ability to see in darkness begins with one quantum particle interacting with a single molecule. You see, because the universe gently taps your eyes with light. Smell may be quantum tunneling in action. Some scientists believe your nose works not just by shape, but by detecting vibrations of molecules. Using quantum tunneling, electrons may tunnel from one part of a molecule to another, depending on the molecule's vibrational energy. This is still debated, but if true, your sense of smell relies on particles passing through the impossible. And every breath you take tonight may be a tiny miracle of physics. Enzymes in your body use quantum mechanics. Enzymes, the proteins that speed up your body's chemistry, rely on quantum tunneling to transfer protons and electrons. These tiny jumps make reactions happen faster than classical physics would allow. Without this, your body would function too slowly to support life. You are alive not in spite of quantum weirdness, but because of it. Quantum randomness might guide your thoughts. Some scientists suggest that quantum fluctuations influence ion channels in neurons, potentially introducing randomness into brain activity. If true, then your thoughts, dreams, and even your choices might carry a faint fingerprint of quantum chance. That stray idea, that sudden memory, it may not be an accident, it may be the dance of probability. Your body's temperature reveals quantum rules. The heat you feel from your skin, your breath, your blanket arises from the motion of particles. But that motion follows quantum energy levels. Atoms don't just vibrate freely. They have quantized modes like notes on a string. And when heat transfers, it does so through these discrete jumps. So the warmth cradling you now is made of invisible steps. Quantum sensors exist in animals. Birds may sense Earth's magnetic field using quantum entanglement. Some fish use electric fields. Certain bacteria can detect magnetic directions at a molecular level. Life, it seems, learned how to tap into quantum effects long before we understood them. Nature whispers in quantum and animals listen. Quantum superposition may be in photosynthesis. Plants use light to make food. But recent studies suggest they do so with remarkable efficiency because of quantum coherence. Energy from sunlight may travel through the plant's internal pathways in multiple directions at once, settling on the most efficient route. So every tree outside your window runs on quantum logic. MRI scans depend on quantum spin. Magnetic resonance imaging works by detecting how atomic nuclei, especially hydrogen, behave in a magnetic field. These nuclei have a property called spin, a quantum characteristic that has no classical equivalent. When the field changes, they emit signals, and we turn those into images of the human body. So even your medical checkups lean on invisible, spinning mysteries. Fireflies glow with quantum energy jumps. Bioluminescence, the soft glow of fireflies and jellyfish, arises from molecules emitting light during chemical reactions. But those molecules emit photons because of energy level transitions, quantum jumps. Nature uses these to communicate, mate, even defend. Each flicker in the dark is a gentle collapse of a wave function. Heat from your tea relies on photon exchange. As your tea cools, it releases infrared photons, tiny packets of thermal radiation. These photons carry away energy into the air. The atoms in the tea vibrate, lose energy, and slow down, all through the quiet exchange of quantum particles of heat. Even cooling down is a quantum ballet. The color of things depends on quantum gaps. Materials reflect certain wavelengths of light, but which they absorb and which they reflect depends on the energy levels of their electrons. These energy gaps are purely quantum. Why is the sky blue? Why are leaves green? Because electrons in air and chlorophyll jump in ways that allow certain photons to survive. Color, it turns out, is not painted on, it's performed. You are constantly being hit by quantum particles, neutrinos, nearly massless, almost undetectable particles, stream through your body by the trillions every second. They pass from the sun through the earth and right through you, without touching anything. They come from stars, supernova, even the Big Bang itself. Right now, ancient particles are moving through you like ghosts of creation. Your atoms are in quantum motion, always. Even at rest, your atoms are never still. They jitter, spin, vibrate, governed by the uncertainty principle. You are a cloud of probabilities, a symphony of interactions. Nothing is ever fixed. Even sleep is motion, but it's quiet motion. Calming, rhythmic, your breath, like your dreams. So as you lie here, a biological being, a conscious observer, a quiet witness, remember, you are not separate from quantum physics. You are quantum physics. You are its masterpiece, its story, its softest echo. You are the experiment and the mystery. The dreaming universe where mystery and sleep become one now. The stars are silent. The particles still dance, but softly like snowflakes. You've drifted through fields and forces, through paradoxes and probabilities. You've touched black holes, photons, atoms, and your own breath. But before we rest fully, there are a few more wonders left. Faint, final ripples in the quantum sea. You are made of star remnants, shaped by quantum rules. Every atom in your body was forged in the core of a star. But the reason stars shine, the reason they explode, the reason they build heavy elements, is quantum fusion. Protons overcome their repulsion through tunneling. Neutrons stabilize atomic cores through the strong nuclear force, itself a quantum interaction. You are not just stardust, you are quantum-stitched stardust. There is no such thing as a nothing. Even in a perfect vacuum, particles appear and vanish, energy fluctuates, and fields ripple. What we call a nothing is filled with potential, bubbling, blinking, jittering with life. The void, as seen by quantum physics, is never empty. So even when all seems still, something is always becoming. Your mind might be a quantum observer. Whether or not consciousness plays a role in collapsing the wave function remains unknown. But the act of awareness, of observing the world, of being here, still matters. You are not passive. You are a participant. Every time you look, you shape. And every time you close your eyes, you rest in that sacred, silent choice. All of reality may be a projection. According to the holographic principle, everything we perceive in 3 dimensions might be encoded on a 2-dimensional boundary far away. In this view, the universe you feel, hear, and see is a projection, much like a dream is a projection of your mind. But that doesn't make it less real. It makes it more beautiful. Probability is the pulse of the universe. Where will this particle go? Which way will it spin? Even with perfect knowledge, the answer is never certain. Quantum physics doesn't offer guarantees, only probabilities. And yet those probabilities form the sun, the moon, the life you know. So it's okay not to know what tomorrow brings. The universe never does. Reality is entangled, so you're never truly alone. At the heart of quantum mechanics lies entanglement, connection, particles linked across time and space. If that's true at the deepest level of matter, maybe it's true for everything. Maybe every thought, every heartbeat, every sleeping breath echoes across the fabric of all things. Tonight, someone else dreams under the same stars, and somehow, in some way, you're connected. Time itself may be a side effect. Some theories propose that time isn't a fundamental feature of the universe, that it emerges, like temperature, from deeper, timeless interactions. That past and future are illusions formed from entangled patterns. So maybe you're not falling asleep in time. Maybe time itself is falling asleep with you. There are more things we don't know than things we do. Despite all the equations and theories, the truth is this. We don't understand the quantum world. Not fully. And maybe we never will. But that's not a flaw. It's a gift. The universe has left us mystery, not to frustrate us, but to comfort us. To remind us that not everything must be solved. Some things are meant to be felt, to be drifted through, to be dreamed. You are part of the story, not just reading it. Every particle in your body, every electron that sparks in your brain, follows the same rules as those in the stars. You are not beside the universe. You are the universe aware of itself for a moment before dissolving into rest. You are the equation, the observer, and the silence between both. Sleep is quantum too. Even your sleep is quantum, your brain waves, your neural states, your dreaming patterns. As you drift between consciousness and stillness, your brain softly collapses and reshapes its own probabilities. Not chaos, choreography. You don't fall asleep by leaving the world. You fall asleep by joining it. The universe is whispering always. It whispers in photons and gravity and radiation and particles, in wave functions and collapsed states. It whispers when atoms fuse and when stars die. It whispered you into existence, and now it whispers you to rest. So listen, not with ears, but with peace. This is not an end, just another transition. Like a particle moving from one state to another, you are not stopping. You are shifting from waking to dreaming, from thinking to floating, from observing to simply being. Sleep is not silence. It is music played in frequencies too soft for day. And now we've reached the end of our journey. But really, there's no end. Only the stillness between mysteries. Sleep well. You are quantum. You are connected. And you are home.